Hello and welcome to the Applied Deep Learning course at the TU Wien. In this course, you're going to learn about machine learning and more specifically about deep learning and how you can apply it to solve challenging tasks that just a few years ago have been considered extremely complex. Before we get started, I would like to briefly introduce myself. My name is Alexander Pacher and I'm currently working as a machine learning engineer at Canva. Apart from being a software developer, I also am a musician and I'm actively singing in the a cappella group Roots and Roots, as well as in the TU Wien core. A couple of years ago, I made a PhD in the field of optical music recognition, where I tried to teach the computer how to read sheet music, as you can see here, to go from an image into something that the computer could, for example, play back to you. As part of this, I started using a lot of deep learning techniques, and the idea was born to also share this knowledge with you. Now this course has already been running for 6 years, and I'm very happy that there are so many interested students like you. You're probably here because you read deep learning and you went, woo! I really would love to learn more about this. I'm pretty sure each one of you has used ChatGPT in the past. So you're like, yep, activate superpowers. Let's go deep learning. Let's learn more about this. And you're definitely not alone. When I started this lecture in 2018, deep learning was at the peak of inflated expectations. It was on the top of this Gartner hype cycle. So it was super hypey. Everyone wanted to do it. Everyone, was interested to getting into it. And this actually has not really changed since. So 2020, I'm just giving you a couple of examples here. You can see there are like 10 different machine learning and AI topics in this hype cycle. Most of them fueled by deep learning. Even the most recent Gartner hype cycle from 2024 again shows several AI and deep learning topics here, like generative AI, AI augmented software engineering, or what I think very interesting, also artificial general intelligence. By the way, there is a similar hype cycle just for artificial intelligence in case you're interested in that. Even though deep learning has been around for a couple of years by now, there's still some, I would say, inflated expectations of people thinking that it can do more than it actually can do. And one really nice example how I can show this is by comparing it to the inflated expectations that people had when the genetic chain scissors CRISPR-Cas9 was developed and first introduced. So let's have a look at this short clip.
Could CRISPR give us unicorns?
So, we're getting creative now. So there are examples of animals that have single horns in the middle. So like the rhinoceros has one at its nose, but there are other ancient rhinoceros that have it in the middle of the head. So anyway, I think that you could get a single horn on a horse by looking at horns in other species.
So it's in the realm of possibility.
Yes.
It's in the realm of possibilities. That's a very nice way to put it. And I think with deep learning, a lot of things are in the realm of possibilities. However, once you get started with it, well, sometimes you might realize it's not necessarily there yet, or we still have to figure out a couple of things, how to get this actually working. So one of the goals that I would like you to take away from this course is to be able to answer the question what can and what cannot be done with deep learning at this point in time. And in order to gain the most understanding of these things, the goal is for you to actually pull off a full deep learning project. So you will be gathering some data, training some machine learning model, and then present the results in a way that everyone can understand what your neural network is doing. And as part of this, I want you to also learn how to present your results properly. Because even if you have the best model, if you cannot show it to anyone, well, how should they know? A few words about this lecture. It is called Applied Deep Learning, and this applied part is actually really important because you will be doing most of the work here. The whole lecture rotates around one big project. And for this project, I want you to work on something and use deep learning to actually solve a challenging task on your own. It will contain 3 assignments where you have to come up with a topic, train a model, and then present the results. In the end, you will also write a short report summarizing all of your findings and present the results in class. The part that I'm contributing to these projects is the theory in the lectures. So what is this project? The project will be one of your choosing. So you can pick a topic and a project type, and it should be something that you really want to, work on. Something that is interesting for you, challenging, and maybe even useful. So that would be the ideal case. Say you have an issue that, a problem that you've always wanted to kind of fix, and now you have the chance to actually try out and see if you can get this problem solved. The project types are as follows. Bring your own data would primarily resolve around gathering a data set for your specific problem. And then you would use an existing approach, an existing architecture, neural network to train on that model. But for example, having a very sophisticated way of rendering images to generate this data set could be a typical example of bring your own data. Bring your own method is exactly flipped. So you would take an existing published dataset and try to come up with a method of training or like solving a particular problem on this existing dataset. Beat the Classics is one of the more challenging project types, which would be implementing a deep learning method and comparing it to a non-deep learning baseline. Say you want to do line recognition in images, well, you can compare it to half-lines and see if you can train a machine learning model to be actually better at detecting lines than a non-deep learning baseline. Last but not least, this is the most challenging type, and I would recommend this only to advanced students, potentially some PhD students that want to actually improve the state of the art. So in this case, you pick a problem, you pick some paper or publication or some kind of baseline that you want to compare against. Ideally, it's the current state of the art, and then you try to beat this. You try to improve the results from this, and in the end, you compare, okay, have I actually managed to beat the stars? If you manage to do so, there is a high chance that you can actually publish this in a scientific journal or conference. How does grading work? For this lecture, the grading is imminent, meaning you will be continuously graded based on the results that you hand in. There are 5 parts, as I mentioned before, the 3 assignments, the report, and the presentation. And there are different criteria that I apply to each of these, which is obviously the results itself, whereby I would like to mention that if you, for example, try to beat the stars and you end up only achieving the baseline, kind of failure would still be acceptable. If you try to solve a very, very challenging problem and you can show afterwards that, you applied the correct practices, but still the problem maybe was too hard for what you were trying to do, then failure is acceptable. Just being lazy and not handing anything in obviously is not. I'm also grading creativity, complexity, and given that we're in a computer science department, code quality. So please be aware that this is an integral part of the software development project. So make sure you name your variables properly, add some tests, add documentation, and make it easy for me to read and understand your code. And lastly, the presentations, of course. How you present your work. Do you properly format everything? Do you shape the outcome in a way that it's easy to be, consumed? This is the scale of how you will be graded. So depending on the number of points you get for the assignments and the final presentation and report, you will be awarded one of these grades. At the end of each assignment, I will let you know how many points you got for it, so you will already understand where you're landing along the way. The 3 assignments are as follows: initiate, hacking, and deliver. So come up with a topic, gather some data, read some papers, plan your work would be number 1. Number 2, implement your idea, try to figure out what exists already, how you can make this actually run. Train the model as much as you can possibly within a limited time scope. Be aware that this assignment usually could take forever, but we only have around 1 month or so for this one, or maybe 2. So time this properly and make sure that you have a running pipeline as soon as possible, that you can have at least some results. And of course, if you still have time, try to improve the methods and optimize as much as you can. And finally, build a small application that shows inference from your model, that actually demonstrates the problem. Given some input data, it should produce some output that you can present, and ideally package this in something that could be shipped or like ran somewhere in a demo to present your results. The logistics for this course are slightly different than in the years before. This lecture remains primarily online. However, there is a small change. So the final presentations this year will be in person. So there are weekly lectures online that I will post and that you can watch with topics that are hopefully useful for your projects. And we also are having weekly Zoom calls if in case there are any questions about your project, about the lecture itself. So you will see all of this in an online learning system that I will share with you in the first lecture. Finally, the last 3 lectures will be in person, and you will be giving 4-minute presentations. So we have quite a couple of presentations to go through. That's why there is a hard 4-minute limit for this. Speaking about the number of participants, there is a maximum of around 60 to 70 students. I already managed to increase this number over the years. However, there will be a limit, because I really think it's important that each one of you gets individual feedback on your project, on your coding, on the things that you hand in. So there might be potentially more interested students. If you unfortunately can't make it within this 60-70 student limit, I'm very sorry, you might have to wait until next year. Speaking of this, I really would encourage you to be aware of the workload of this lecture. While in theory you can probably code this project in 40 to 50 hours, in the past students found it very engaging and often spent upwards of 100 hours on their projects. So be prepared that this might be a quite intense lecture in terms of the coding and the efforts that you have to put into it. So if you sign up, please only sign up if you're aware of this and know that you have the extra capacity to complete the project. It would be very sad if you take a spot from someone else who wants to take the class, and then after the first assignment you drop out and someone else could have taken the class. So just be fair to your colleagues. In this you will see there is a preceding course, which is the Deep Learning for Visual Computing. This is a very nice course that I took myself many years ago, and it's interesting because it delves a bit deeper into certain topics of visual computing that I cannot go that deep into. So if you've taken this course before, that's great. In case you haven't taken it before, I recommend taking it maybe after this lecture, because it's still very helpful to also see and work on a project specifically in the image domain. Last words about logistics. The projects that you will be working on your own. While teamwork is great, I believe you will be able to learn the most if you actually code yourself. If you get stuck somewhere, try to figure out what the solution is and then fix it yourself. That doesn't mean that you shouldn't talk to your colleagues. Please talk to each other, help each other out, ask questions, use the online forum for questions, and help your peers. But for the project itself, for the implementation, I would like you to work on your own. You unfortunately also have to bring your own computing resources. So if you have a computer with a modern graphics card, there is a high chance that you can train some smaller scale models on your own on this machine. In case you don't have a graphics card because you just have a laptop, there are some online resources that you can use for this. For example, Google Colab, which will also be how I will be sharing the examples from this lecture. But there are also a couple of other services online where some of them are free, some you need to pay a little bit of money, where you can train your machine learning models. This is the schedule for the winter semester. I'm trying to put as much interesting content online as soon as I can to make it helpful for your projects. Be aware that if you're working on a project with explainable AI, for example, that the corresponding lecture will only happen towards the end of this course. There are 3 assignments. These are important dates. So they're always the day before one of the lectures. And especially for the last deadline, I want to point out that on the 13th of January, I want to receive all of your final presentations and the reports. And the reason is that on the 14th, the first students will present their submissions and you will be randomly picked. And in order to make this process fair and not have anyone have 2 weeks more than their colleagues, all of your presentations have to be handed in by the 13th of January. That's all for now. I hope that this answers most of the organizational questions that you had so far. I hope to see many of you in class. And with that, let's dive right into it.